this is winter 2017, okay, paper 2-1, question 2b. Okay. There are L and M, which are chlorides of an element in period 3. Then a student investigated both L and M, and the results are here. Now, L is a white crystalline solid with a melting point of 987 Kelvin, which is quite high. Then L dissolves in water to form an approximately neutral solution. That means pH is not 7 but close to 7. Addition of sodium hydroxide to an aqueous solution of L produces a white precipitate. Okay, so this student added sodium hydroxide. That means the pH of this solution is not 7 but close to 7 and is below 7. They add sodium hydroxide, that means the solution is acidic. So addition of sodium hydroxide, L produces a white precipitate. So the hydroxide of the metal in this L, is a white precipitate. That means it's not soluble in water. Okay, now let's look at M. M is a liquid with a boiling point of 331 Kelvin. Okay, very much lower than L. Then M is hydrolyzed by cold water to form a strongly acidic solution, a white solid and white fumes. So now M is a liquid. Just now L is a solid. M has a lower boiling point compared to L. M can be hydrolyzed. Okay, just now L dissolves in water. Now M reacts with water. Okay, we get white solid and white film. Now this question is asking us to identify L and M. Then you have to explain any properties and observation described. Okay, and give equations where appropriate. Now let's try to identify L first. Okay, L is a solid. Dissolve in water to form acidic solution that is close to neutral. Alright, now I have this table here which shows the chlorides of period 3 together with their physical and also chemical properties. Now, just now L that we saw in the question was a solid. Sodium chloride, magnesium chloride, aluminium chloride, they are solid. The rest are liquid. Okay, PCl5 is also a solid. Now, it dissolves in water to form an approximately neutral solution. So look at the pH of the solution. It is not neutral, so cannot be sodium chloride. Okay. Magnesium chloride, yes, close to neutral. Okay, the rest are very acidic. So L is magnesium chloride. Now magnesium chloride, when added sodium hydroxide, because it's acidic, it will form magnesium hydroxide. Now we know that magnesium hydroxide is not soluble in water, or sparingly soluble in water, so it will give you a white precipitate. That is not soluble in water. So L confirmed is magnesium chloride. Okay, so we go back to the question. We know that L is magnesium chloride. Okay. Right, now explanation. Okay, you can explain from any points from in the results. For example, I want to say, this produces a white precipitate, right? So what's a white precipitate? It's actually magnesium hydroxide. Okay, is a white precipitate. Okay, that will give you 1 mark. Now we need 2 explanations because there are 3 marks. So 1 mark for the identity, 2 marks for the explanation. Okay, right. Now we can look at, you can write an equation. So I can write equation to show that, how magnesium chloride forms magnesium hydroxide. Okay, it is the reaction between magnesium chloride and sodium hydroxide. Again, it is mentioned in the question. Okay, we are only explaining. Do not forget to balance the equation. So I need 2Cl. That means 2Na. Alright, now that gives us all 3 points. Let us move on to M. Okay, identifying what is M. Now M is a liquid this time, hydrolyzed to form a strongly acidic solution, white solid, white fumes. Now we'll go back to the table again. Right, this time M is a liquid. Now we have two liquids here, silicon chloride and also phosphorus trichloride. Both are liquids. Both gives acidic, very acidic solution when they react with water. And yeah, they do. Okay, they can be hydrolyzed by water. Now let's show you another table, okay, which shows all the reactions of chlorides with water. Okay. Now, we only look at silicon chloride and phosphorus trichloride because they are liquids, right? So silicon chloride reacts with water, hydrolyzed by water to form white solid and HCl fumes. Phosphorus trichloride reacts with water, we get phosphoric acid, phosphorus acid, and also HCl film. Now, just now in the question, we saw that hydrolysis of this M will give us a white solid and also white fumes. This is a white solid and white fume. Here, no solid. Okay, there's only white fume. So M is silicon chloride. Now, again, let's go back to the question and let's answer the question. So, what is M? M is silicon chloride. Okay, now what's the other 2 points that we should write? M is hydrolyzed by cold water to form a strongly acidic solution, a white solid. Okay, we can say that the white solid is actually silicon 4 oxide. Okay, sorry for the typo. Let me correct this. Okay. Right, what other things that you can write? Okay, we can talk about the white film. Okay, HCl is the white film. Okay, done. We got the other 3 points. Okay, for identifying M and the explanation. Now, I have students who asked me about the mark scheme. Okay, the answer scheme for this question. So we look at the answer scheme. Okay, question 2b, this whole thing. Particularly this part, hydrolysis of silicon chloride is possible due to available d orbital. So what does it mean? Okay, now silicon chloride undergoes certain mechanism for this hydrolysis. So what happened was I have silicon bonded to 4 chlorine. This is SiCl4. Okay. So because silicon is less electronegative compared to chlorine, so this bond is actually polar, right? With silicon having the partial positive charge, chlorine partial negative. Okay, sorry about that. Okay, now all these are partial negative. Hydrolysis means this silicon chloride is reacting with water. Now let me use different color for water. Now the lone pair of the water is attracted to the partial positive silicon. So it will attract the silicon. Right. Now you see, then silicon will actually form an intermediate. Sorry, this whole thing forms intermediate. Okay, let's draw smaller because okay, run your space here should have written it on the more to the left hand side at CL, CL, and CL. Okay, now of course this is living. So now I have a positive charge here. Okay, what happened is then this bond like this, and then here. Sorry about that. Okay, now can you see that this intermediate, okay, silicon now is surrounded by 10 electrons. Okay, to achieve octet, okay, all atoms, the outermost electrons must be 8 only, but now we have 10. And why it can form this intermediate is because silicon has empty 3D orbitals. Now you know 3D orbitals, there are 5. Okay, there are 5 3D orbitals. If they are empty, so silicon can accept, okay, maximum of 5 lone pairs. But now it has only accepted 1 lone pair from O. Okay, so then of course this initially will give you silicon oxide and also HCl, right? But yeah, the reason why this can occur is because silicon has empty 3D orbitals, available 3D orbitals. Okay, that is why this is accepted as one of the answers as explanation.